Hello everyone. So in this video we will see the methods of analyzing electrical circuits. So in this video we will see about nodal analysis, mesh analysis, super node, super mesh, all these concepts. Whatever we can cover in this video we will cover. Okay? Yeah. So before starting, just some basic things like what will be the current I here? What will be the value? V by R, right? V is at, we are considering V is at higher potential, ground is at lower potential. So from higher potential to ground, what is the current flowing? V by R, right? Now in this diagram, what is the value of current I1 and what is the value of current I2? You should write down. Current will always flow from high to low potential. So if considering the direction of I1, V1 is the higher potential, right? And considering the direction of I2, V2 is the higher potential, right? Also, there is one more relation, I1 is equals to minus I2, right? Now in this you simply need to apply the KVL. Okay, you need to apply the KVL. So how will you apply? From here you will start. Let's consider this is ground. So this potential will be V. Here we will have a drop of IR1. All this we have already understood, right? Just revising it. Here we will have a drop of IR2 and like that. So plus V minus IR1 minus IR2 minus IR3 minus IR4 equals to 0. So V is equals to IR1 plus IR2 plus IR3 plus IR4. So basically what is happening here? What is happening here? The potential V is getting divided into IR1, IR2, IR3 and IR4. This is what is happening here. Okay. This potential V is getting divided into these resistance. So V is getting divided into IR1, IR2, IR3, IR4. So whenever there is a current flowing out of the positive terminal of battery, the current is flowing out of the positive terminal of battery and getting into the resistance. That means the applied potential will be equals to the voltage drop across all the resistance. So like, are you able to visualize? This potential is getting drop across all the resistances. So whenever we apply KVL from next time onwards, we will not write these kind of equations. We will directly try to write the expression. Okay, because we know what is the direction. From here to here, if we are going, this V is positive. From here to here, if we are going, this is negative, this is also negative, this is also negative, this is also negative. So all four are negative and one is positive. So one thing we will keep at the left hand side of the equal sign, and one thing we will keep at the right side of the equal sign. Are you getting it? The one which is positive we will keep at the left hand side, one which is negative we will keep at the right hand side. So that's how we will apply the KVL. Let's see more examples. In this question, if we go from here to here, this is positive, and then we are just assuming that I current is flowing like this. So if we go from here to here, this is positive, all this will be on the other side. So V would be equals to IR1 plus IR2 plus IR3. Why so? Because the drop will be like this, right? And we are moving this way. So if we are going from here, this will be positive, this will be negative, this will be negative, this will be negative, this will also be negative. So it will come here, right? This is how directly we will apply the KVL now. Okay. Now in this question, let's start from here. V is positive. Now let me draw the direction. This is I. So V is positive. This will be negative. This will be negative. This will be negative. This will be positive. Right? We are moving like this. So from here to here, positive, negative, 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 and positive. So positive ones will be in the left hand side of the equal. So V plus V1 equals to IR1 plus IR2 plus IR3. Are you getting this point? So basically, like, if you start from here, if this is 0, what is the potential of this point? V1. If this is 0, what is the potential of this point? V1. Now if this is 0, because this is 0, then this is also 0. What is the potential of this point? Minus V1. So between the potential will be minus V1. So between V and minus V1, there are three resistance. So between here is V, here we have minus V. So between V and minus V1, there are three resistances, R1, R2 and R3. So what is the current flowing through? What is the current flowing? That will be V plus V1, because V minus of minus V1 upon R1 plus R2 plus R3 equals to I. So from here also you can write V plus V1 equals to IR1 plus IR2 plus IR3. You can see that, right? The similar manner in which we wrote down this V minus V2 upon R equals to I1. So like that you need to see. Okay. And while writing KVL, you should always move in one direction. We are moving like this, then you should always move in this direction. You can't go like this. Okay. You are completely moving in this direction only. So you are starting 0, V1, IR1, IR2, IR3 plus V1. That's it. Okay. Now some simple question. You need to find the value of V0 in this circuit. Try finding it on your own. You need to find the value of V0. This current source will also have some drop, right? Just like that, there is some current out of a voltage source. This is a voltage source, this is a current source. So when there is a voltage out, when there is a current out of a voltage source, that means even the current source will have some voltage drop, right? So the current source will also have some voltage drop. So what is the amount of voltage drop it is having? Look, this 1 ampere current, this 2 ohm, this 2 ohm is connected in series with 1 ampere current source, right? So this 1 ampere current will be flowing here as well, right? This 1 ampere current will be flowing here as well. Because of this 1 ampere, this will have a voltage drop of 2 volt in this direction. From high potential to low potential in this direction, this will have a voltage drop of 2 volt. Let's assume if this is 0, then what will be the value of V0? V0 will be 4 minus 2 equals to 2 volts, right? We started from here 0, 4, this will be 4, this will be 4 minus 2, and that is equals to V0 only, because if this potential is 0, this potential will be V0. So V0 is 4 minus 2, or you simply need to apply the KVL. So how will you apply? 4 minus 2 minus V0 equals to 0. You will apply like this: 4 minus 2 minus V0 equals to 0. So V0 will come out to be 2 volt. Okay, well and good. Okay, great. Now this 4 volt is, now you need to find the value of I. So this 4 volt will be across this resistance, right? This 4 volt will also be across this 2 ohm current source, as 2 ampere current source as well. But this 4 volt will be across this 2 ohm resistance. That is for sure, right? So if this 4 volt is across this 2 ohm resistance, then what is the current flowing here? Tell me. Direction will be like this, from high potential to low potential. So the value will be 2 ampere. So what will be the value of I? I will be 2 ampere plus 2 ampere, right? 2 ampere plus 2 ampere equals to 4 ampere. Are you getting it? I will be equals to 4 ampere, right? 4 volt, 2 ampere, 2 ampere. So total current will be 4 ampere, right? Now we will see nodal analysis. So this is the analysis what we use maximum times. Okay, we use maximum time this analysis only, but it depends on the question. So maximum time we will use this analysis only. So we will consider it, we will understand this with the help of a question only. Okay, it will be very easy. It is a very basic analysis. You must have studied in 12th class as well. Okay, so let's see. Okay, so in this circuit, do you know the potential of this point? Yes, we know this is 0. If this is 0, this will also be 0. If this is 0, this will also be 0. Will this also be 0? No, because this will have a voltage drop, right? So this 10 ampere current source will have some voltage drop, so this can't be 0. Okay, so let's assume this potential is V1. Do you know the potential of this point? No. Let's assume the potential of this point is V2. Okay, so this is V1 and this point is V2. Okay, this point is V2. Now we will apply nodal analysis. What is nodal analysis? Nodal analysis is basically KCL. Okay, nodal analysis is KCL. So I will write applying nodal analysis. Applying nodal analysis at V1. At node V1, we are applying the nodal analysis. So tell me, we will write outgoing current as positive and incoming current as negative. So tell me, what is the current here? V1 by 6. What is the current here in this direction? Outgoing current. Outgoing current. We are writing outgoing current. So that will be V1 minus V2 by 4. So from V1 node, there are how many branches connected? 1, 2, 3 and 4. So in all four branches, we will write down the current. Okay. While applying nodal analysis, many times student forget some branch. Okay. So you just need to see if you are writing the current in all four branches. Okay. So we will start. So first current we can see V1 by 6, that is outgoing, plus this current is also outgoing, V1 minus V2 by 4, plus 5 ampere current is also outgoing. 5 ampere, not, we will not write ampere, 5. Okay, 5 ampere current is also outgoing, 5. 10 ampere current is incoming, right? The 10 ampere current is coming into this node. The 10 ampere current is coming into V1 node, so it is incoming. So you will write minus 10 equals to 0, or what you can write, equals to 10, right? You can directly write equals to 10. Look, V1 by 6 plus V1 minus V2 by 4 plus 5 minus 10 equals to 0 or equals to 10. So this is the first equation. The second equation, applying nodal at the rate V2. So let's apply nodal at V2. So what is the current in this branch? V1 by 2 ampere, right? 5 ampere current is coming here. And what is the current in this branch? If we are writing the outgoing current, in this direction, if we are writing, so the current will be V2 minus V1 by 4, right? In downward direction V1 by 2, and here V2 minus V1 by 4, and 5 ampere current is coming inside. So basically how we will write, V2 by 2 plus V2 minus V1 by 4. Now no one will say that here you are writing V1 minus V2 by 4 and here you are writing V2 minus V1 by 4. Why so? Because we are writing outgoing current. For this node, the outgoing current is V2 minus V1 by 4. Okay, if you had considered this current only, so for node V2, this V1 minus V2 by 4 current is incoming, right? So you would have put a minus sign there. So that minus sign would give plus V2 minus V1 by 4. Are you getting it? V1 minus V2 by 4 is a incoming current for node V2. For this node, it's a incoming current, right? So what you will do? You will put a negative sign. So basically it will give you V2 minus V1 by 4, positive only. Or you can simply take the outgoing current. So we are taking only the outgoing currents. So this is the outgoing current. Now 5 ampere current is incoming. So equal to 5. So the incoming current will be equals to outgoing current. Okay. Incoming current. So at the left hand side we are writing outgoing current. At the left hand side we are writing outgoing current equals to incoming current. Okay. Well and good. Okay, so this is the second equation. Now you have two variable and two equations. Just solve them up and you will get the value of V1 and V2. V1 and V2. I will check whatever the value we are getting. Okay, so we are getting V1 equals to 20 volts and V2 equals to 40 by 3 volt. Okay, so this is the final answer. Okay, very simple. Let's move on to this question. Again, you need to find the value of these two nodes. Again, you need to find the value of potential of these two nodes. Let's call this one as V1, this one as V2. Also, in this question, if they had asked you what is the current in 6 ohm resistance, what is the value of current in 6 ohm resistance? So what will be the answer? 20 by 6 ampere, right? 20 volts is there, 20 by 6 ampere. What is the value of current in 4 ohm resistance? You need to mention the direction. Here 20 by 6 ampere is this, and here the current will be in this direction. That will be 20 minus 40 by 3 by 4, right? What is the value of current in 2 ohm resistance? That will be 10 ampere, right? So are you getting this point? Very easy. So in the next question you need to find the nodal voltages. Okay, I will write nodal voltages. nodal voltages you need to find. Okay, so let's just apply nodal analysis. So nodal at V1, I will change the pen. Nodal at V1, so that will be V1 by 4 plus V1 minus V2 by 5 equals to 14 ampere. Are you getting it? V1 by 4 current in downward direction means outgoing, V1 minus V2 by 5 outgoing current, and 14 ampere current is incoming. Outgoing current, incoming current. That's it. This is first equation. Then again nodal at the rate V2. And how will you solve these equations? Very simple, no? I don't think I need to tell the solution of these equations. Okay, let's just solve this equation. Okay, otherwise people will say I am not solving. So what is the LCM? LCM will be 20. So 5V1 plus 4V1 minus 4V2 equals to 20 to 80. Okay, so it will simply be 9V1 I can write. This will simply be 9V1 minus 4V2 equals to 20 to 80. Right? So this is equation 1. Now nodal at V2. By substitution method you can solve. Okay. So nodal at V2 will give me V2 minus V1 by 5 plus V2 by 5 minus 7 equals to 0. Right? V2 minus V1 by 5 outgoing current. V2 by 5 outgoing current. 7 ampere is also outgoing current. So sorry, it is plus. 7 ampere is also outgoing current. So it will be plus. Right? So 2V2 minus V1 equals to minus 35. Right? This is equation 2. Now you have to make the equation like this, so you can multiply it with 9. So multiplying the equation with 9. Multiplying equation 2 by 9. It will be 18V2 minus 9V1. What is minus 35 into 9? 350 में से 35 less कर दो. It will be minus 315. Okay. Now you can add up equation 1 and 3. I will just write down the equation here. Adding equation 1 and 3. I'm just solving the equation, nothing else. So you will add up the equation 1 and 3. So you will get 14V2 equals to 280 and minus 15 minus 315. That will be equals to minus 35. So V2 will be equals to minus 35 by 14. And now by this equation you can get the value of V1 as well. So V2 is minus 35 by 14. I will check the value of V1. So your V1 is 30 volts. Okay. You can clearly see V2 is minus 2.5, right? This is minus 2.5. So if you put minus 2.5 here, it will be minus 5 and it will go here. So it will become V1 will become plus 30. Okay. So V2 is minus 35 by 14 and V1 is plus 30. Okay. Well and good. Easy question. Let's move on to next question. Again, you need to find the nodal voltages, or just think we need to find the value of Ix. Find Ix. Okay. This is the question for you. So what is Ix? It is current dependent current source. This is 2Ix, sorry. This is current dependent, current controlled current source, right? Current controlled current source, right? Now let's assume we have a voltage V1 here, V2 here, and V3 here. Again, we will solve it by applying nodal analysis, or you can apply other methods too, but let's solve it making nodal analysis only. I will just write down the equation. You need to solve the equation on your own. Okay. So let's apply the nodal analysis. So nodal at V1, that will be V1 minus V2 by 2 ohm plus V1 minus V3 by 4 ohm equals to 3 ampere. Are you getting it? V1 minus V2 by 2, V1 minus V3 by 4 equals to 3 ampere, right? Equation 1. Nodal at the rate at nodal at V2. So that will be V1 minus V2, V2 minus V1 by 2, outgoing current we are writing, V2 minus V1 by 2 plus V2 minus V1, V2 minus V3 by 8 plus V2 by 4 equals to 0. All are outgoing current. V1 minus V2 by V2 minus V1 by 2, V2 minus V3 by 8 and V1 V2 by 4. All are outgoing current. Now nodal at V3, that would be V3 minus V2 by 8 plus V3 minus V1 by 4 plus 2Ix equals to 0. That is equation 3. 2Ix, outgoing current, V3 minus V2 by 8, V3 minus V1 by 4, outgoing current, plus 2Ix, that is also outgoing current. Also, what is the value of Ix? Tell me. What is Ix? Ix is V1 minus V2 by 2 is equals to Ix. Are you getting this point? Just see the direction of Ix. Ix is V1 minus V2 by 2. That is Ix. The current in 2 ohm resistance, that is V1 minus V2 by 2. So you have 4 equations and 4 variables. Basically, you have 4 equations, 4 variables. Okay, you will solve it and you will get the value of V1, V2, V3, V4. So no V4 is there. V1, V2, V3 and Ix. Okay, I will just check the values and write it down. Now solving the equation is on your own. Okay, and the next thing is that these kind of questions can be asked in semester exam. Okay, but it is very rare that they will ask such high calculative question in gate exam. If they are asking question in gate exam, they will not involve this much calculation. But in semester exam, they can ask you these kind of questions. But in gate exam, the calculation will surely be less. Okay, so you don't need to worry. Okay, so I will just check the answer and we'll write down the final answer. So these are your final answer. V1 is 4.8 volt, V2 is 2.4 volt, V3 is minus 2.4 volt and Ix is 1.2 ampere. So Ix will be simply by putting the values here. So that will be 4.8 minus 2.4 by 2. That will be Ix. Okay. Let's see this concept, the concept of supernode. Okay. So you don't need to consider it as a different concept. It is not a different concept. It is simply whatever we have studied. That's the same thing only. Okay. So we are not thinking we are applying supernode or anything like that. We are just solving the problem. So how will you solve this problem? Applying the node analysis. So let's solve this problem applying the nodal analysis. So applying nodal at V1. So applying nodal at V1. What will be the current in this branch? V1 by 2 ampere. The current here is 2 ampere. The current in this branch will be V1 minus V2 by 10, right? So let's just write it. V1 by 2 plus V1 minus V2 by 10 minus 2 equals to 0. Is it fine? Is it all correct? Yes or no? No. Why so? Why so? Because I told you one thing, always see the current in all the branches. You have written the current in this branch, in this branch, in this branch. You didn't consider the current in this branch. Even the voltage source can have some current, no? Right? So we can consider a current here, that is I1 current is flowing here. Okay? Or we can consider in this direction as well, I2 current. Or we can consider in this direction. So it depends on you where you will consider the current. In this direction as well you can consider, in this direction as well you can consider. I am considering the current in this direction. I1 current is flowing like this. Okay. So plus I1 equals to 0, right? Outgoing current we are writing as positive. Okay, now nodal at the rate, why I am calling it at the rate, nodal at V2, it will be V2 by 4 plus 7 plus V2 minus V1 by 10, right? V2 by 4, V2 by 4 and then 7 ampere current outgoing, then plus V2 minus V1 by 10, the current here, V2 minus V1 by 10 equals to I1, right? This current is equals to I1. Why so? Because I1 is the incoming current. You could have written I2 here, then you would write I2 equals to minus I1. That doesn't make any sense. I am just considering this I1 current. So I1 current is incoming, so I am writing it equals to I1. Now by equation 1 and 2, what you can see? V1 by 2 plus V1 minus V2 by 10 minus 2 plus V2 by 4 plus 7 plus V2 minus V1 by 10 equals to 0. What did I do? I just put the value of I1 here, replacing I1. Okay, I just replaced the I1 value. So what is happening? This and this is getting cancelled, right? This and this is getting cancelled. So basically you are left with 2 V1 plus V2. This will be minus 5 and then multiplied with 4, 20. This is the third equation you are getting. 2V1 plus V2 equals to 20. Is that fine? Multiplied with 4. This also multiplied with 4. This was minus 5. Yeah. So 2V1 plus V2 equals to 20. There is one more equation. What is the value of V2 in terms of V1? That is V1 plus 2. If the potential of this point with respect to ground is V1, then what will be the potential of this point with respect to ground? V1 plus V2. We are coming from here to here. So V2 is equals to V1 plus 2. V2 is equals to V1 plus 2. So V2 is equals to V1 plus 2 volt. This is fourth equation. By equation 3 and 4, what did you understand? 2V1, so V1 we can replace with, okay, V2 we will replace with V1 plus 2, okay, 2V1 plus V1 plus 2 equals to 20, yeah, right. 3V1 equals to 18, V1 equals to 6 volts and V2 equals to 8 volts. This is the final answer we are getting, right? So what is one different thing we can do? Look, there is this common branch, right? There is this common branch between V1 and V2, right? This is the common branch between V1 and V2. So basically there is this common branch and V2 can be written as V1. V2 can be written in terms of V1 or V1 can be written in terms of V2, whatever we can say. So whenever there is a common branch between two nodes and one node can be written in terms of the other node, there is a common branch and one node can be written in terms of the other node, then we can ignore the current in the common branch. Okay, so I will write down this statement. When I will just pause it and write because it will just waste your time. So what is supernode? When there is a common branch between two nodes and the potential of a particular point can be written in terms of the potential of the other node or point, then while applying the nodal analysis you can ignore the current in common branch. Okay, there is this common branch, potential of V1 can be written in terms of V2 or potential of V2 can be written in terms of V1. Now while apply and and V2 is the yeah, that thing I repeated. Okay, so now while applying the nodal analysis, you can ignore the current in 2 volt and 10 ohm resistance. Okay, then now you can apply the KVL. Okay, so I will just copy that diagram and then just we will apply the KVL. So now we will apply the KCL, not KVL, the KCL. KCL we will apply now. Okay, so here we will apply KCL. How we will apply? This is V1, V2 will be V1 plus 2, right? V2 will be V1 plus 2. So by the concept of supernode. Look, if you don't want to remember this, if you think you will do some error while applying this concept, then you don't need to apply it. Just simply consider a current, then also you will be able to solve. Okay. Even if I had been at your place and during examination I would haven't applied any concept of supernode. Okay, I would just take the current and just replace it. Okay, because in these kind of concept there is high chances of doing some error. Like sometimes you may think we can apply the supernode, but in reality you can't really apply the supernode. Sometimes it may happen. So for safety I wouldn't apply this concept, but I will give you one more perspective of this concept, one more way of seeing this concept, then it will be all easy for you. So we will see it in next slide, but let's just complete it by the concept of supernode. How we will apply? V1 by 2 ohm, then here there is 2 ampere current incoming, so minus 2 plus V1 plus 2. We are coming at this node now, V1 plus 2, because we are ignoring the current in common branch. So now we have come here, so we will ignore the current in these two branches. We will just write down the current in these two branches. So it will be V1 plus V2 by 4 plus 7 equals to 0. So all this is reduced to only one variable and one equation. So from here you will get the value of V1. So your V1 will be 6 volts, V1 will be 6 volt, and V2 is V1 plus 2. So V2 will be 8 volts. Okay. So all this is reduced to only one equation and one variable. Okay. Although this will also not take you much time. It may seem that it will take so much time for writing this equation, but slowly you will be able to understand that this will not take much time. But let's see one more perspective. Okay, one more way of looking at the circuit. One more way of okay, I will just redraw the circuit in my way. There is this current source, then there is 2 ohm resistance, there is this 2 ohm resistance, then there are 10 ohm and 2 volt battery, 10 ohm and 2 volt battery, then there is 4 ohm and 7 ampere, 4 ohm and 7 ampere, and all these are connected, all are connected to ground. 7 ampere, 2, 10, 4, 2 ampere, 10 ohm and 4 ohm. Is that it? Yeah. Okay, look, now you know the value of this potential, that is V1. Now this is V2, right? V1, V2. Okay, now tell me one thing. Okay, you know the current in this branch, V1 by 2. You know the current in this branch, 2 ampere. There will be some current going here. Look, what I am doing, I am like making this, I am making some modification here. 10 ohm and 2 volt, just connecting to these 2 points, just connecting these 2 points together, and making it one node here. So both of the nodes are same. So basically there will be some current V1 getting out here. Are you getting this point? some current I1, sorry, not V1, there will be some current I1 getting out of here, not I1, I will call it I, okay, there will be some current I here. Now this current will get divided into two branches, here and here. Let's call this one as I1, this one as I2. This I current is getting divided into two branches, I1 plus I2, okay. Now this I1 plus I2 will collectively give me again I current here. I had I current here divided into two branches, I1, I2, and again collectively give me I current. So basically what I am doing here is that I am applying my nodal V1 by 2 minus 2 plus I1 equals to 0. Now what is the value of I1? What is the value of I1? This I1 current is getting divided into two parts. This I1 current is again getting divided into these two parts, right? So the value of I1 is V2 by 4 plus 7 equals to 0. Now what is the value of V2 in terms of V1? That is V1 plus 2. So this is also a way of looking at it. Are you getting this point? There is this I1 current that is getting divided into two ports, that is getting divided into two branches, then collectively giving me only one current. So that one current is equals to the current in these two branches. So I know the expression of this current in terms of these two branches, and here also I know the expression of this current in terms of these two branches. So finally I can write only one equation and get my answer. Did you get this point? You got it, right? So this is also a way of looking at it. So while dealing with complex circuit in analog electronics, this is how I will build your intuitions, or in the complete chapter I will build your intuitions. Just see the tangent analysis video once, okay? You will know like how do we see the circuits. I current is coming, getting divided, I current is coming, now I can write the expression. So this is how also you can write the expression. So we will again get the values. V1 equals to 4 volt, I guess, 6 volts, and V2 equals to 8 volts. Okay, this is also a way of looking at it. Okay, so let's see the next part. Okay, before that we will solve one question, then we will see the mesh analysis. Okay, so in this question you will find the value of V1, V2, V3. Also you can find the value of I as well. Okay, I will just modify the question. Find the value of V1, V2, V3 and I. Okay, so let's just do one thing. This is V1, this is current I. What is the value of V2? V2 is V1 minus 25 volt. What is the value of V3? V3 is V2 plus 55, right? V3 is V2 plus 55. What is V2? V1 minus 25 plus 55. This is V3. This is equation 1. This is equation 2. Now tell me what is the value of I? I is equals to V1 by 2. Are you agreeing? I is equals to V1 by 2. Right? So now what does V3 become? V1 minus 25 plus 5 V1 by 2. So V3 is coming as V1 only. 3.5 V1 minus 25. This is the value of V3. Now what you can see? V2 and V3 are written in expression of V1. V1 minus 25, 3.5 V1 minus 25. So V1, V2 and V3 are written as an expression of V1 only. And there are some common branches. So you can ignore those common branches and just write down one equation. So I will just write down one equation. So what are the common branches? Between V1 and V2, this is the common branch. Between V1 and V3, this is the common branch. Between V2 and V3, this is the common branch. Okay, because V3 can also be written in terms of V2. V3 can also be written in terms of V2. Okay, and also it can be written in terms of V1 as well. So you can ignore the current in all these branches. Okay, because these are common branch between each other. Although it's risky to apply the concept like this. Okay, if I were at your place, I would assume some current and then solve it. Okay, but in the exam, if there is no time left, you can apply this concept directly. So I will just write down one equation and we'll get the final answer. So we will just write down the current. So nodal analysis. So nodal at V1 by supernode. V1 by 2. This branch we are ignoring. Now simply we will come to V2 plus, what is the value of V2? V2 is V1 minus 25. So V1 minus 25 by 4. The current here, outgoing current we are writing. The outgoing current we will write. Like this is the outgoing current. This would have been the incoming current. So V1 by 2 outgoing current, V2 by 4, this is also outgoing current, plus V3 by 6, because we are ignoring the current in this branch. From V2 there are 3 branches connected, 1, 2 and 3. We have wrote the current in this branch. From V3 there are 3 branches connected, 1, 2 and 3. We will write the current in this branch only. So plus V3 by 3, or what is the value of V3? That is 3.5 V1 minus 25 by 3 equals to 0. So from here you will get all the values. From here you will get the value of V1, then you can get the value of V2. Okay, then you can get the, if you know the value of V1, you will get the value of V3, and if you know the value of V1, you can get the value of I as well. So from here you will get the V1, V2, V3 and I. Okay, I will check the answer and write down the value. So I hope you have understood the concept. What I did, I just wrote down the expression in terms of each other. Okay, and just show the common branches and then ignore the current in those common branches and just write down one equation, and this is the final answer we are getting. Okay, so final answer I will tell you. So this is the final answer. The calculation is a bit complex part, but we just wanted to see the concept here. Okay, so this is the concept and this is the final answer. Okay, calculation is a bit tough part here. Okay, let's move on to next topic, that is mesh analysis. Okay, so till now we have applied the nodal analysis. Now we will apply the mesh analysis. We can also apply it, like in any circuit we can apply nodal and mesh, both of the part. Okay, so I can try solving the question. By both of the analysis here. So first we will apply mesh analysis. Okay, so what is mesh? Mesh is loop. Okay, mesh basically is loop only. Loop. So what we need to do, we need to consider current in loops. So let's just consider I1 current in this loop. So what does this mean? So that means this I1 current is flowing in this branch. Okay, this I1 current is also flowing in this branch, but it's not certain that only I1 current will be flowing. Some other current can also flow. Okay, so let's just assume in this loop we are having I1 current and in this loop we are having I2 current. So what do you think, what will be the current flowing in this branch? I2 only, because there is no component of I1 current in this branch. So what will be the current in this branch? Only I2. What will be the current in this branch? What do you think? What will be the current in this branch? That will be I1 minus I2, right? I1 current is going downward and I2 current is going upward. So I1 minus I2. Are you getting this point? Or you can see, if I1 current is here and I2 current is going that way, that means in this branch I1 minus I2 current will be going, right? I1 current is coming here, I2 current is going that way, that means here I1 minus I2 current would be there. 5 ampere current coming here, 3 ampere current is going there, that means 5 minus 3 current will be going that side. Simple KCL, right? So in diagram we show it like this. This is the loop, this is also a loop, like this arrow. This is a loop, this is also a loop. I1 current is going downward, I2 current is going upward. So the current in downward direction would be I1 minus I2. Let's assume 5 ampere current is going downward, 4 ampere current is going upward. That means total current 1 ampere is flowing downward. Okay, so that's how we show. Now we just need to apply KVL. So basically mesh analysis is your KVL. So in loop 1, so in loop 1 what is happening? 15 is equals to 5I1 plus 10 I1 minus I2 plus 10. Did you get this point? What you can do, what will be the drop? This will be positive, this will be negative, this will be negative, this will also be negative. So positive equals to negative plus negative plus negative. From here to here you will come, let's assume this is ground. From here to here you will come, this will be 15, this will be minus 5 I1, this will be minus 10 I1 minus I2, this will be minus 10. So we are writing the positive one at right hand side and the negative one at the left hand side. So that's how we wrote the equation. Okay. So 5 is equals to 15 I1 minus 10 I2. This is equation 1. In loop 2, what we will see in loop 2. So in loop 2, from where we can start? We can start from 10 here. We will move like this. You can move like anyhow. Okay. Wherever you, however you want to move, you can move like you can move like that. Okay. So I'm moving like this. Okay, like this. Okay. So I will start from here. What will be the potential of this point? 10 plus 10, right? Plus 10. What will be the potential of this point? The current is flowing from up to down, I1 minus I2. The current is flowing from up to down, I1 minus I2. That means this will be positive, this will be negative. The current is flowing like this, I1 minus I2. So from higher to lower potential. So this will be negative, this will be positive. So if this point is plus 10, then this point will be plus 10 into I1 minus I2, right? So this will also be positive. Plus 10 into I1 minus I2. Resistance into current. Simply the current is I1 minus I2 in this direction. That means upward will be positive, lower will be negative. So we are going like this. So from here plus 10, then 10 into I1 minus I2. Now we will work like this, right? We will work like this. So if we are working like this, that means here we will have positive, here we will have negative, right? The current direction is like this. Not for working. Okay, forget about your working. We need to see the direction of current. So the direction of current is like this, from here to here. So now we are working like this. So from here we are coming, from here to here we will see negative. And from in this branch as well, the current is like this. So from here to here we will also see negative. You just first need to see the current. On the basis of the current, you will make the voltage drop, plus minus, then you will work. That's it. First you will make the voltage drops and then you will work. So making the voltage drop, here we will have positive, here we will have negative, here we will have negative, and here also we will have positive. So positive one side and negative one side. So that will be equals to 6I2 plus 4I2. Negative ones at this side, positive ones at this side. So this is the final equation that we are getting. Okay. So I can narrow it down like this. 10 will be equals to 20I2 minus 10I1. Equation 2. So we can solve the equation 1 and 2. This will be 30I1 and 10. 30I1 and 10. Then we will add up these two, 40, 20I1. So I1 will be 2 ampere. I1 will be basically 2 ampere. Okay. And I2 will be 1.5. I1 will be 2 ampere and I2 will be 20, 30 by 20, 1.5 ampere. Let me recheck once. Okay. Yeah. So the answer is correct. Okay. Now we will solve the same question with nodal analysis. Okay. The same question with nodal analysis. Okay. So do you know the potential of this point? Yes, I know it will be 0. Do you know the potential of this point? Yes, I know it will be 15 volt. What will be the potential of this point? That will be 10 volt. What will be the potential of this point? You don't know. Let's consider it as V. Do you want to know the potential of this point? This point? No, I don't want to know the potential of this point because the current, this 6 ohm and 4 ohm are in series, right? This 6 and 4 are in series. So I can directly write it at 10 ohm. From ground to potential V, I have 10 ohm resistance. From ground to potential V, I have 10 ohm resistance. Are you agreeing with this point? From ground to potential V, I have 10 ohm resistance. Are you agreeing with this point? I hope you are agreeing, right? So now I can simply apply the nodal analysis. How will I apply the nodal? So let's not write 15V, let's just write 10. Let's just write 10. Okay. So you don't need to see those current and all. Okay. So just nodal analysis we are applying. V minus 15 by 5 plus V minus 10 by 10 plus V by 6 plus 4 or 10. Right? Are you getting this point? So it will be 2V minus 30 plus 2V minus 10 equals to 0. So V equals to 8 volts. Okay, V equals to 8 volts. V equals to 8 volt we are getting. So what did we need to find? We needed to find this current. Let's call this one as I1 and let's call this one as I2. So the I1 current will be what? Am I solving it right? V1 minus 15 by 5, V1 minus 10 by 10 plus V1 by 10. Okay. So 2V minus 10 equals 2V minus 30. So it will be 4V minus 40. So V would be 10. V would be 10 volts. Okay. Now I need to find the value of I1. So I1 will be 15 minus 10 by 5. I1 will be 15 minus 10 by 5. That means 1 ampere. What is happening there? Okay, so I did a mistake here actually. I solved the equations wrong. So the answer would be 1 ampere and 1 ampere. I'm really sorry for that mistake. So answer would be I1 would be equals to 1 ampere, I2 will also be equals to 1 ampere. Okay, so I'm really sorry for that mistake. So here as well you will see I1 equals to 1 ampere, and what will be the value of I2? I2 will be equals to 10 by 10. 10 by, this potential is 10, 10 by 10. I2 will be equals to 1 ampere. Why is it 10 by 10? Here we have 10 volt potential. So 10 volt by total resistance, that is 10 ohm. So 10 by 10, that will be equals to 1 ampere. So I1 and I2 both are equals to 1 ampere. Here also we were getting 1 ampere. I just made a calculation mistake here. Okay. So this is how we can solve the problems. Okay. So let's move on to the next problem. You need to find the value of I1 and I2. You should solve it on your own. I1 and I2. What will be the first step you will do? You will mark down the potential in the direction of current. Okay, we are taking I1 direction in this side. Here as well we will have I1 here. In this branch we will have I1 minus I2, right? In this branch we will have I1 from upside, I2 from downward side. So I1 minus I2. Here we will have I2 branch in this side, and here we will have I2 branch, I2 current in this side. I2 current in this side, I2 current in this side. Okay. So based on that, this will be plus, this will be minus, 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 this will be plus, this will be minus. This potential is already plus, this potential is also plus. If we are going from, if we are starting from here now. Okay. So in loop 1, you will apply the KVL. In loop 1. In loop 1. So let's assume I am working like this. I am working like this. This is how I am working. Okay. So I will start down from here. From here to here I will come negative sign, minus 4I1. Look, if this is 0, this will not be 0. Here we have resistance this time. In all the time we were saying that this was completely grounded, but here we have resistance this time. If this is 0, this will not be 0. If you take this one as 0, this will not be 0. So only this node can be 0 now. So if this is 0, this will be minus 4I1. This will be plus 90. This will be minus 6I1. And then this will be minus 10 I1 minus I2. That's it. We have worked around the complete loop. From here we started. From this point we started, then moved here, then moved here, then moved here, then moved again here. Right? 0, minus 4i1 plus 90 minus 6i1 minus 10 i1 minus i2. Okay, this is equation 1. Now you will write down the equation in loop 2 as well, in loop 2. Okay, so how will you work? You can work in any direction. I will work like this. Okay, I am working like this. I will write down work. You can work in any direction. I am working like this. Okay, I am working like this. So I am working like this. So I am starting from here. Okay, so if this is 0, next one will be 5i2 plus 40 plus 15i2 minus 10 i1 minus i2 equals to 0. Okay, so this will be equation 2. Okay, so you can solve the equation 1 and 2 on your own, right? You can solve it at 2 equation and 2 variable, and then you will get the value of i1 and i2. Okay, I will just write down the final values. So I hope you have got the concept. We just noted down the current direction. So when you will be too much comfortable with all these kind of problems, you will not need to draw any current. Okay, in the air only you will be able to see the currents. So I1 current is going that way, I2 current is going that way, or you can make the current in this direction as well. It depends on you. Okay, so I1 is going that way, I2 is coming that way. So you can write down the equation based on that. First draw the potential drop and then just work in the circuit. Just keep on working. Make the potential drop and then keep on working. So we have made the potential drop and we worked like this. 0 minus 4i1 plus 90 minus 6i1 minus 10 i1 minus i2 equals to 0. In this loop we worked like this. 0 plus 5i2 plus 40 plus 15 i2 minus 10 i1 minus i2 equals to 0. So now we will solve i1 and i2 value we will get. Okay, so i1 is 4.6 and i2 is 0.2 ampere. Okay, so in this question you need to find the value of i0. Find i0. Try doing it on your own. It may be calculative. Okay, there can be calculations, but you can do it on your own. There will be 3 loops: i1, i2 and i3. So tell me what will be the current in this branch? That will be i1 minus i2, right? What will be the current in this branch? That will be component of i1 will also be there and component of i3 will also be there. But if I am writing in this direction, i1 is flowing like this, i3 is flowing like this. Okay, what will be the current in this branch? You can make any direction. I am making this direction. Okay, so I think I need a space here, so let's make it like this. So i2 is coming that way, so i2, and i3 is going that way, so i2 minus i3. Now what will be the current in this resistance? That will simply be i2. So you know the current in all the resistance now. Okay, now you in every loop you will work in loop 1, in loop 2 and in loop 3. I will just write down the equations and then you can get your answer. So what is basically i0? I0 is i1 minus i2. This is the first equation. The second equation will be 24 equals to 10 i1 minus i2 plus 12 i1 minus i3. We are going in this loop. 24 equals to, the current direction is like this. The current is getting out of the positive terminal. So if we start like this, if this is 0, this is 0, this will be 24, this will be plus minus plus minus plus minus plus minus. So 24 equals to minus 10 i1 minus i2 minus 10 i1 minus i3. So 12, sorry, minus 12 i1 minus i3. So I wrote it like this. Okay, this will be equation 2. Now let's see equation 3. So we are working like this. So I can work from here to here. So 4 i0 minus, I am working in loop 3. Okay, so from here to here, this is 4 i0 minus 4 i1 minus i2 minus 12 i1 minus i3 equals to 0, or I can write it like this, right? So this is, I'm writing I2 minus I2, I2 minus I3 should be 4 I2 minus I3 it should be. So this current is basically I2 minus I3. Okay, there was small error. So 4 I naught minus 4 into I2 minus I3 minus 12 I1 minus I3. So I can write it as equal. So positive ones at this side, negative ones at this side. Okay, now I will work in this loop. So how am I working? I will work in any way you can work. Okay, so you can work like this. Need to make it. I will work like this here. Okay, I'm working like this. So here you need to see, this is an interesting one. Okay, so in the complete loop you will write, you can start from any point, you can start from this point. I told you one thing, you can assume any potential or you can simply drop this as well. Let's just consider the potential of this point is V, or 4 I naught it is. I know that the potential of this point is 4 I naught. Let's just consider the potential of this point is V. So V minus 4 I2 minus I3 plus 10 I1 minus I2 minus 24 I2. Now we have again come to this potential. We started from here, then we went here, then we went here, then we went here, again came to the same potential. What is the value of that potential? That is equals to V. So V and V will simply get cancelled. So let's just not write V. Let's just simply write equals to 0. So basically you started from here, some potential minus 4 I2 minus I3 plus 10 I1 minus I2 minus 24 I2 equals to 0. Okay, so that will be equation 4. So by solving equation 1, 2, 3, 4, solving equation 1, 2, 3 and 4, you will get the values. So I will just write down the value of I naught. Okay, yeah, okay, so answer came out to be 1.5 ampere. Okay, so let's just move to next thing, that is the concept of super mesh. You don't need to think there is any concept or anything like that. This is a simple problem. Okay, you just need to solve, that's it. You can solve the rest of the problems with nodal analysis as well. If you solve this by nodal analysis, it will take a lot of time, because this potential, you know, this will be 24. Okay, this is 0, this will be 24. This will you have to assume V1, this will you have to assume V2, or you can assume this as 4 I naught, and then you will write the value of I naught in terms of V1 as well. Okay, so I guess this will be easier with nodal analysis. Okay, you can try. This will be easier with nodal analysis. This potential you will get to know easily, because even the value of this potential will be written in this term, in the term of this potential. Let's just assume if I make this potential as V. Okay, then what will be the value of I naught? I naught will be 24 minus V by 10. That will be I naught. And what is the value of what is the value of this potential? That is 4 I naught. Now you know the value of I naught in terms of V. The value of I naught in terms of V is 4 V minus 24 by 10. Oh, sorry, 24 minus V by 10. The value of I naught in terms of V is 24 minus V by 10. And now you know the potential of this point, that is 4 I naught. That means 4 into 24 minus V by 10. So in only in one variable you can get the value of this potential V. Then you can find the value of I naught. So this will be easier with nodal analysis actually. So solve homework I can write. Solve by nodal on your own. On your own means homework only. So I don't need to write this on your own. Solve by nodal analysis. Okay, just assume the potential V here. Okay, V potential here. Let's just see the concept of supernode. This is just a simple problem. You don't need to think we are applying supernode or anything like that. Just a simple problem. Okay, if I am making I1 current like this and I2 current like this, so tell me what is the value of current in this branch? I1. Now I1 current is coming here and 6 ampere current is coming here. So what will be the value of current here? That will be 6 plus I1, right? I1 current coming from here, 6 ampere current is coming from here. This is the current source. So this will always give 6 ampere current, no matter whatever the potential it has. So it will certainly give 6 ampere current. So basically here I2 is 6 plus I1, right? I2 is 6 plus I1. I1 current is coming here, 6 ampere current is coming from here. So the total current will be 6 plus I1. Okay. So now what we will do? We will apply the nodal analysis in this loop. Sorry, the mesh analysis in this loop. Okay. Loop 1 okay. Mesh or KCL, simply KVL in L1 in loop 1. Why we are applying KVL in loop 1? Because we will only have one variable, that will be I1. That's it. Right? So we are starting from here. If this is 0, this will be 20 minus 6 I1 minus 10 into I1 plus 6 minus 4 into I1 plus 6. Or basically in 14 ohm resistance, 10 ohm plus 4, 14 ohm resistance, you have 6 plus I1 current. So 14 into 6 plus I1 also you could have written, right? So 20 will be equals to 14 plus 10, 14 plus 6, 20 I1, and this is 60 and 24. So it will be 84. Okay. So 64 and 20 I1 value we will get minus 64 by 20. Okay. So solving from here, I1 will be 3.2 ampere and your I2 will be minus 3.2 actually, minus 3.2, and your I2 will be 2.8 ampere. So these are the final answer. So basically supernode is not a different concept. It is just a nodal, it is just a mesh analysis only. Super mesh is not a different concept, it is just a mesh analysis. Just like supernode, that was not a different concept, that was just a nodal analysis. So here you can see we just ignore the current in this branch because we know the current in outer branch, so we just write down only one equation. We just want to write down only one equation. So I1 current and 6 ampere, so I1 plus 6. So whenever there is a chance of super mesh, I will surely apply it in the exam. Why so? Because here I can directly see the currents. Okay, whenever we are dealing with currents, it is easier. I1 current 6 ampere, so I1 plus 6. But when we are dealing with voltages, it is a bit difficult sometimes. So when we are dealing with currents, it is easier. I1 and 6, so I1 plus 6. So just apply the mesh analysis in this loop. 20 equals to 6 I1 equals to 10, or 10 plus 4, 14. So 20 equals to 6 I1 plus 14 into 6 plus I1. That's it. I1 and I2 value will be there. Okay, I will not apply two equations here, even in the exam. If I apply two equations here, then what will happen? I will also have to achieve my voltage here. So if I apply the mesh analysis or KVL in this loop, I will write down 20 equals to 20 minus 6 I1 minus 2 I1 minus I2 minus V equals to 0. Then I will write down in this loop, then I will need to find the value of V, I1 and I2. So that will be a big problem. That will be a big problem that will give rise to big equations. So I don't want that. I just want I1 plus 6. That's it. Okay. So I1, I2 value we will get. Okay, then in the next video we will see a lot of problems based on mesh analysis and nodal analysis. So it is just the practice. How much practice you will do, that much comfortable you will be. Okay, so it depends on the practice. So we will solve a lot of questions. Okay, then if you are liking the video, please do share it. Okay, thank you.